So, hello everyone. In today's lecture, we are going to discuss some important problems, or we are going to practice some important problems based on the rotation theorem in the complex number. Got it? So, here's the first problem. The first problem says that given Z1, Z2, and Z3, Z1, Z2, and Z3, they are given the three complex number, and they said are the vertices of equilateral triangle. The Z1, Z2, and Z3 are the vertices of a equilateral triangle whose centroid is at origin. Centroid is at origin. G is at origin. If Z1 is 1 plus iota, Z1 complex number they gave is 1 plus iota, then find Z2 and Z3. Got it? We have to find the other two coordinates, one coordinates they gave in an equilateral triangle. And one more thing, they have given the centroid of this triangle. Centroid of this triangle, they said the centroid of this triangle is at origin. It means 0, 0. Now next. It is an equilateral triangle. So equilateral triangle means all the angles will be 60, 60, and 60. This complete angle is how much? 60 degrees. If this complete angle is 60 degrees, we can say the half of this will be how much? 30 degrees. Similarly, this also will be 30 degrees. If these two are 30 degrees in the triangle GZ1, Z3, this angle will be 120 degree. Got it? So if this angle is 120 degree, we can say that from this complex number Z1, we can get Z3 by rotating the complex number Z1 with the angle 120 degree in anti-clockwise direction, right? So here we're going to do that. This complex number Z1 is 1 plus iota. So if the complex number Z1, if I multiply with E iota, e to the power iota 120 degree means 2 pi by 3, right? 2 pi by 3. We are going to get the complex number Z3. So we'll solve this one. Z1 is 1 plus iota, and e to the power iota 2 pi by 3 I can write in polar form. This will be cos 2 pi by 3 plus iota sine 2 pi by 3. Got it? Now next, what is cos 2 pi by 3? Cos 120 degree. Cos 120 degree is minus 1 by 2, right? 90. Minus 1 by 2 plus sine 120 is root 3 by 2 iota root 3 by 2 multiplied by 1 plus iota. So now we multiply. So 1 multiplied by minus 2 is minus 1 by 2. 1 multiplied by iota root 3 by 2 is plus iota root 3 by 2. Iota multiplied by minus 1 by 2 is minus iota by 2. Iota multiplied by this is plus iota square root 3 by 2. Got it? Now next we can write this as minus 1 by 2 plus iota root 3 by 2 minus iota by 2, and this iota square is nothing but minus 1, right? So minus root 3 by 2. So here we can separate the real parts and imaginary parts. So we'll write this as minus 1 plus root 3 by 2 by taking minus 1 common from this term and this term, the real terms, and from the remaining two terms I'll take iota common. So plus iota root 3 minus 1 by 2. Okay, so this is the complex number Z3. So our complex number Z3 is minus 1 plus root 3 by 2 plus iota root 3 minus 1 by 2. Got it? Now next we'll try to find the complex number Z2. Now Z2 also, this angle is 120 degree, right? We can say that we can get Z2 from Z1 by rotating Z1 with 180 degree but in clockwise direction, right? So how to rotate in clockwise direction? To rotate in clockwise direction, I'll multiply Z1 with e to the power minus iota 2 pi by 3, right? So this will give my Z2. Now we calculate what is Z1. Z1 is 1 plus iota, and this if I write in polar form, I get cos minus 2 pi by 3 plus iota sine minus 2 pi by 3. What is cos 120 degree minus 120 degree? Cos minus 120 degree is same as cos plus 120 degree, which is minus 1 by 2 plus iota sine minus 2 by 3. Sine minus 120 degree is minus sine 120 degree, and sine 120 degree is root 3 by 2. So here I will get iota multiplied by minus root 3 by 2. And here I am having 1 plus iota. Now we'll multiply these two complex numbers. So if we multiply, we get 1 multiplied by minus 2 is minus 1 by 2. 1 multiplied by uh, this is minus root 3 by 2, not the root of minus 3 by 2. This will be minus root 3 by 2. So minus root 3 by 2. Got it. Now next, 1 multiplied by minus 1 by 2 is minus 1 by 2. Next, I'll multiply this. So I'll get iota root 3 by 2 minus root 3 by 2. Next, iota I'll multiply. So here I'll get minus iota by 2 plus iota square minus root 3 by 2. So iota square is minus 1. So minus into minus plus. So here I'll get plus root 3 by 2 minus iota by 2. And here I also get minus iota root 3 by 2 plus minus 1 by 2. Got it. Now next, I can take minus iota common from these two, and these two real terms I can write together. So this will be root 3 minus 1 by 2, and I'll take minus iota common. So here I get root 3 plus 1 by 2. This is my complex number Z2. So my complex number Z2 is root 3 minus 1 by 2 minus iota root 3 plus 1 by 2. Got it? We found the other two complex numbers Z2 and Z3, or other two vertices of the equilateral triangle. Got it? Now next question is, they have given a square, and what are the vertices of square? Vertices of square are Z1, Z2, Z3 and Z. Got it? Now they're saying find the following ratios. Find the following ratios means Z4 minus, first ratio Z4 minus Z1 and Z2 minus Z1. Where is Z4 minus Z1? Z4 minus Z1 is this vector. Is this vector, right? Z4 minus Z1 is this vector, and Z2 minus Z1. Z2 minus Z1 is this vector. Z2 minus Z1 is this vector. Got it? So what I can write here? I can write here that this Z2 minus Z1, if I will rotate this Z2 minus Z1 with 90 degree, I'll get this Z4 minus Z1, right? So I can write here Z2 minus Z1 rotated by 90 degree means I multiply with e to the power iota pi by 2. So we will get Z4 minus Z1. Got it? Now Z2 minus Z1 I can send down. So here I will get e to the power iota pi by 2 is Z4 minus Z1 upon Z2 minus Z1. This is my required ratio. So here the required ratio will be e to the power iota pi by 2. Or if I expand this one, this will be cos pi by 2 plus iota sine pi by 2. Okay, so what is cos 90? Cos 90 is 0, right? And what is sine 90? 1. So this will be equal to iota. This ratio is equal to iota. Now similarly, second one. Similarly, second one. Second one they said Z1 minus Z2. Z1 minus Z2. So where is Z1 minus Z2? Z1 minus Z2 represents this vector. This is Z1 minus Z2. Now next, they said for Z3 minus Z4. Z3 minus Z4 is this vector. Z3 minus Z4 is this vector. Now, if we'll see clearly, if we'll see clearly, this vector I can bring here, this vector I can bring here, and I can write this. This one is my vector z1 minus z2, and this one is the vector z3 minus z4. Got it? So how I can get z1 minus z2? How I can get z1 minus z2 from z3 minus z4? By rotating this vector with 180 degree in anti-clockwise direction. So I'll write the equation. So here I can write that z3 minus z4 I'll rotate with the angle pi by 2, sorry, pi e to the power iota pi to get z1 minus z2. Now we'll divide with this. So here we'll get e to the power iota pi is z1 minus z2 upon z3 minus z4 upon z3 minus z4. And what is, so this ratio is what? This ratio is e to the power iota pi. Got it? Now, what is e to the power iota pi? E to the power iota pi I can write as cos pi plus iota sin pi. Got it? Cos pi is what? -1, and sin pi is 0. So here we'll get -1 e to the power iota pi value as -1. So this one I can write as -1 also. This one I can write as -1 also. -1 also. Got it? Now next one. Next one they asked for z4 minus z2. Where is z4 minus z2? This is z4 minus z2. This is z4 minus z2. This one is my z4 minus z2 vector. Got it? Now next, another vector is z3 minus z1. Z3 minus z1 is this vector. Z3 minus z1 is this vector. Got it? So how to get these vectors? See. So if I want to rotate and get from one vector to another vector, so I'll make their initial point same. So what I'll do, I'll move this vector and I'll place it here. Got it? What is the angle between these two vectors? The angle between these two vectors now is 90 degrees. The angle between these two vectors is 90 degrees. Got it? So here, when I will move these vectors and I'll make their initial point same, the angle between them still will be 90 degree only. The angle between them still will be 90 degree. Still this angle will be 90 degree. So because we can move the vectors parallelly, right? We can move the vectors parallelly. So we can say that this angle is 90 degree. This vector is z4 minus z3, and this vector is z3 minus z1. Got it? So we'll rotate. So if z3 minus z1 vector, z3 minus z1 vector, if we'll rotate with e to the power iota pi by 2, we will get z4 minus z3 vector, right? Z4 minus z2 vector, sorry. Z4 minus z2 vector. This is z2. Z4 minus z2. Got it? Now next, we'll divide with z3 minus z1. So we'll get here e to the power iota pi by 2 is equals to z4 minus z2 upon z3 minus z1. Got it? So what is e to the power iota pi by 2? Just here also we found that e to the power iota pi by 2 is nothing but iota. So the answer for this one is e to the power iota pi by 2, or this one you can write as simply as iota also. Got it? Now next question. Next question they said z1 plus z2 plus z4. Z2 plus z4 and z1 plus z3. Z3. This they want. Now tell me what I'll get after adding z4 and z2, or we'll find the midpoints. We can do this question by finding midpoint. The midpoint of z2 and z4. What is the midpoint of z2 and z4? It is It is z2 plus z4 by 2. So here somewhere I'll get the midpoint. And what is the midpoint of z3 and z1? The midpoint of z3 and z1 is the midpoint of z3 and z1. The midpoint of z3 and z1 will be z1 plus z3 upon 2, right? And tell me these 2 points are same. In a square, the midpoint of diagonals are same, right? This is what this point is. What this point is the midpoint of diagonal. This point is the midpoint of diagonal. So if we will join this also, the midpoint of z1 and z3 will be same as midpoint of z4 and z2. So these 2 points are same. So these 2 points are same. This midpoint and this point are exactly same. And right here that these 2 points are or represents same point. So if we will divide both of them, we'll get here z2 plus z4 by 2 and z1 plus z3 by 2, right? 2 got cancelled. Here we got z2 plus z4 and z1 plus z3. Now this one represents the same point, this one represents the same point. So we can say that these two will get cancelled and our answer will be 1. So the value of this ratio will be 1. Got it? Because this is also a same complex number. So represents the same point means this is the same complex number and this one is also same complex. Got it? Same complex number divided by same complex number will give 1. Now next, come to this question. In this question, they have given a square and they've given the complex number representing z1 and the complex number z0. Z0 is the center of the square. Now they're saying to find the other vertices of the square. Z1 they gave, Z0 they gave, which is the center. Z2 they are asking to find us. Z3 also they are asking to find, and Z4 also they are asking to find. Right. So what I'll do here, I'll join. I'll make the diagonals. So if I make a diagonal, center is the meeting point of diagonals for a square. Center is the meeting point of diagonal for a square. So now next, so this is center coordinates they gave 1, 1 means the z0 is 1 plus 1 iota. Now next we know this vector, right? If we write this vector, what is this vector? This vector is z1 minus z0. Z1 minus z0. And what is the angle between the diagonals in a square? The angle between the diagonals in the square is 90 degrees, right? So means if this vector is z1 minus z0, if I rotate with 90 degrees in anti-clockwise direction, I'll get z2 minus z0. Yes or no? By rotation theorem. So here z1 minus z0 multiplied by e to the power iota pi by 2 to rotate. We used to multiply with this side. So we will get z2 minus z0. Now it's easy. Now we'll find what is z1 minus z0. Z1 minus z0 is 2 plus 3 iota minus 1 minus 1 iota. Got it? And e to the power iota pi by 2 is nothing but iota. Will give z2 minus z0. Z0 we know 1 plus 1 iota. Now from here we can find z2. First we'll multiply. We'll get here 2 minus 1, 1, 3 iota minus iota is minus 2 plus 2 iota. Multiplied by iota is equals to z2 minus 1 plus iota. Now this iota will multiply iota plus 2 iota square. 2 iota square means minus 2. Z2 minus 1 plus iota. 1 plus iota I will send to that side. So here I will get minus 2 plus iota plus 1 plus iota is equals to Z2. From here minus 2 plus 1 is minus 1, right? And iota plus iota is plus 2 iota. This is the value of Z2. This is the value of Z2. So z2 we got, z2 is minus 1 plus 2 iota. Now next, z3. How to find z3? To find z3, I'll rotate z1 minus z0 vector with 180 degree in anti-clockwise direction. 180 degree in anti-clockwise direction. Got it? So here we'll find C in same way. So z1 minus z0 vector, I will rotate with e to the power iota pi to get z3 minus z0 vector. So now what is z1 minus z0? z1 minus z0 is 2 plus 3 iota minus 1 plus iota. And what is e to the power iota pi? It is cos pi plus iota sin pi. And here I get z3 minus z0. z0 is 1 plus iota. Now what is cos pi? Cos pi is minus 1 and sin pi is 0. So this overall is minus 1 ohm. So we'll calculate 2 minus 1 is 2 minus 1 is 1. 3 minus 3 iota minus iota is plus 2 iota. And this will give minus a is equals to z3 minus 1 plus iota. So z3 value will be, send this 1 plus iota to that side. So 1 plus iota minus 1 plus 2 iota. So z3 from here will be 1 minus 1 cancelled, 1 minus 2 iota will give minus iota. So z3 here will be minus iota. Got it? Now next, how to find z4? Z4, to get z4, I'll rotate the z1 minus z0 vector with 90 degrees but in clockwise direction. Got it? So we'll find so z1 minus z0 vector will find z1 minus z0 vector. I'll rotate with 90 degree in clockwise direction. That's why I'll multiply with minus 5. So this will give me z4 minus z0. Now what is z1 minus z0? z1 minus z0 will give 2 plus 3 iota minus 1 plus iota. And e to the power minus 5 by 2 means cos minus 5 by 2 plus iota sine minus 5 by 2 is equals to z4 minus 1 plus iota. Got it? Now we'll solve this one. 2 minus iota, 1 is 1, 3 minus iota is plus 2 iota multiplied by cos 90. Cos minus 90 is cos 90, cos 90 is 0. This will be 0. This value is 0. And this value will be minus 1. So minus 1 into iota is minus iota. Here I'll be multiplying it with minus iota to get z4 minus 1 plus iota. So here I'll get minus iota minus 2 iota square. This 1 plus iota I'll send to that side. I'll get plus 1 plus iota is equals to z4. So minus iota plus iota got cancelled. And here I'm having iota square. Iota square is minus 1. This will be plus 2 plus 1. So z4 will be 3. Z4 is 3. So we got all the vertices of this square. And the vertices of this square. Z3 is purely imaginary and Z4 is purely real. Got it? Now next देखिए, if the area of triangle formed by complex number z, iota z, and z plus iota z is 8, find modulus of z. Now listen, if we will try to plot this complex number, suppose somewhere here my complex number z is there. This one is my complex number z, and the modulus of this complex number is mod z. Now I told you to remember that e to the power iota pi by 2 is nothing but iota. So multiplying this z with iota to get iota z complex number is same as multiplying this complex number z with e to the power iota pi by 2, because both are same, right? So this complex number I'm going to multiply with e to the power iota pi by 2. So z, if I multiply with zi, again write as z multiplied by e to the power iota pi by 2. That means we'll get this zi by rotating this complex number z with 90 degree. So if you rotate this complex number z with 90 degree, I'll get a complex number. This complex number is Iz. And what is the magnitude? The magnitude of this complex number is z. And the angle, this angle is 90 degree. We rotated with the angle 90 degree. Now next, if we consider this as vector position vector z, this as Iz. So where is I plus Iz? Sorry, z plus Iz. Z plus Iz will be my complex number, this complex number. Z plus Iz will be this complex number by vector addition. This I can assume as z plus Iz. So clearly we can see that this point, this line OZ, this line OIZ is having same magnitude and they are perpendicular to each other. So we can say that this is nothing but a right isosceles triangle. A right isosceles triangle. Now what is the area of right isosceles triangle? The right isosceles triangle is area is half into base into height. If this side I will consider as my base, this side will be my height. So this will be half. What is the length of the base? The length of the base is modulus of z. What is the height of the this height means this side. This is side length. But this side length is also modulus of z. So this will be half into modulus of z square. And what they gave, the area is 8 square units, right? So the area will be 8. From here we can say that modulus of z square is 16 or modulus of z is 4. Modulus of z is 4. Got it? So the vector representation of a complex number and the rotation of the complex number is very or the most important topics in the complex number. Many PYQs have been asked by these two topics in complex number. So prepare these two topics properly. Till now, these two are very important topics, right? Thank you. Meet you in the next lecture.